In this lecture, we would be talking about a very interesting application which we see quite frequently in the internet environment, namely streaming multimedia applications. Now, I am sure many of you are familiar with some kind of streaming applications over the internet. In this lecture, we try to talk about the basic technology behind this kind of streaming applications and how we can guarantee or achieve the desired performance or the so called quality of service parameters as demanded by the various applications. So, streaming multimedia applications, this is the topic today. So, we start by talking something about multimedia networking, how multimedia can be transported over a network. Now, first let us try to understand what do we mean by multimedia applications. Multimedia applications are some applications which deal with one or more of the following data types: text, images, audio, video. These are examples. Now, some examples of such multimedia applications may be a media player in which you are playing a video. Your browser is also a good example of a multimedia application where you can have embedded video, embedded audio, images, text, everything together. Okay. So, your browser is a very powerful and flexible kind of a multimedia application, you can say. Sometimes you will find that what the application in question, there are some kind of configurations you can make in order to improve the quality of the multimedia that is being showed or displayed or played on it. So, we will basically try to address those points first. So, I had said that this kind of multimedia information transmission is the most common scenario today. Whenever we browse the internet, we download a page, they will invariably contain some multimedia content. So, transmission, processing and rendering of multimedia information over the network, this is the main challenge. Some example applications are shown here. Some common multimedia applications. See, by multimedia application I am not just telling that you are downloading a page and you are displaying it on the screen. I am talking about something more demanding, like you are downloading something which has a built-in audio which has to be played. It has a built-in video clip which has to be played. This kind of things I am talking about. So, the common applications we see in the internet scenario are streaming stored audio and video, streaming live audio and video, and real-time interactive audio and video. Now, we will be talking about the details of these three, but as the name implies, the first one refers to something which is stored somewhere. Second one, you are trying to broadcast something live, and the third one, there is an interactive nature of the communication. So, these keywords actually signify the main differences in the way they will work, but whichever application you talk of, stored, live or interactive, whichever way, all of the above share some common characteristics. Most important is the delay characteristics. Delay characteristics or the delay sensitivity says that the end-to-end packet delay. This end-to-end packet delay is important. Suppose I am playing a video clip or an audio clip which I am downloading from some web server from somewhere else. Now, if the end-to-end packet delay is very large or is variable, then the quality of playback will not be very good. Okay. So, delay sensitivity, one is of course the packet delay, that means how long it takes to reach me, and secondly variability of the delay. Well, if all packets are equally delayed, then possibly it will not be that much of a problem to me, but if the delay varies, then during playback I may encounter some breaks and jitters in between. This is called delay jitter. Jitters caused due to variability of packet delays. But this kind of applications, multimedia application, often can tolerate packet losses. Suppose when you are downloading say a voice application, a music, streaming music you are downloading, the music packets are coming one after the other, you are playing. Suppose one packet in between is lost, and if you do not take any special mechanism to recover that lost packet and straight away go on playing whatever comes after that, then with respect to the audio quality you will possibly feel a small glitch in between. Other than that, you will not find any major cause of confusion or annoyance, because there will be no gap in between. That means you need to wait for the correct packet to come back again, you wait for that amount of time. So, those kind of gaps or delays in betweens are typically not allowed. So, those packets you can easily drop, and these kind of applications can tolerate few packet losses. As I said, small number of such losses can cause some small or minor disturbance during playback. If you look at the data transmission requirement, when you transmit some data, transmit a file over the network, requirements are just the reverse there. For data transmission you cannot tolerate any loss, your data has to reach the other end without any loss. However, here delay variations can be tolerated. So, as you can see that the requirements of multimedia applications are orthogonally different from the requirements of a standard data applications. Okay. So, and the point to notice that the network as we see today, that were built with the data applications in mind, but now that we have multimedia applications, we would have to do whatever we can do best on top of the network which was primarily built for data. Okay. This is something you should keep in mind. Some quality of service categories with respect to the applications, you can classify between hard QoS and soft QoS. For hard quality of service, the application may malfunction if the constraints cannot be met. Some typical examples are critical patient monitoring systems or a missile control system. For a patient monitoring system, it depends on what you are monitoring. If you cannot take corrective action within a defined period of time, then the life of the patient may be under threat. Similarly, for a missile control system, you know that you have a certain defined period of time between the detection of the missile which is coming towards you and the retaliatory action to stop and intercept it, because if you cannot act within that time, possibly the missile will be hitting you, right. So, these are some applications where the quality of service parameters are very hard, but there are soft QoS where even if it changes a little bit here and there, users really do not care that much. Functionally applications will perform correctly, but there will be some variations in the quality. Typical examples are multimedia applications. So, multimedia applications usually fall under the soft QoS category. Now, let us look at the three different kinds of streaming multimedia types that we had talked about. The first one we talk about is streaming source stored multimedia. So, I said that the multimedia is stored in some place. The basic concept is like this. Here you are trying to play a media file over the network. The basic media file, it can be audio, video, is assumed to be stored at the source. When you want to play it over the network, the file has to be transmitted to the client. the idea is like this. I am the client, I want to play or view a video clip. The video clip is stored somewhere in some other server. I download the file from there. It is a stored video clip on that server. But the difference is that in a normal data download, I first complete downloading my file, then I start playing it. In contrast, in a streaming multimedia, the video starts get playing as soon as the first few packets of the video have started to arrive. So, as the packets are coming, I am continuously going on playing. Okay, this is something of a continuous playing as the data is coming mode, so that I am not waiting for the entire time for the file to get downloaded. That time I am saving. This is the central concept of streaming. The client starts playing the media before the whole of it is transferred. But in order to have a good quality of playback, minimum continuous rate of transfer has to be ensured. If we cannot ensure this, then there will be jitters in the playback, there will be disturbance, there will be some gaps or delays, right. Okay. So, the picture looks like this for this mode of transmission. The client is out here, the media is stored on some server out here, and you have the internet in between. The client sends the request through the internet, and the media will be sent or transmitted as data packets over the internet, and as the packets come, they get played. So, the client is playing a part of the video and the server is sending the next part of the video. These two are carried out in an overlapping fashion. So, as the client, I will get a part of the video file, I will start playing it, and while it is being played, the remaining portion is coming continuously. So, retrieving the data and playing back the part already come, that has already arrived, these two things are carried out in an overlap fashion. There is an overlap there. And in this mode, the typical functionality that is supported by the client are pause. I can pause playback, there is no problem here. Fast forward, well, fast forward, what I can do is that I can say that you start playing from 1 minute, after 1 minute. Well, here you can implement it, but you will have to wait till that portion of the file has reached you before you can start the playback again. Okay, but you can have this fast forward feature. But there is some other way also. You can send an explicit request to the server that you start sending from this offset onwards. If that support you have, you can start playing much earlier. Play, rewind, all these things are there. Play, of course I have mentioned. Rewind is since the data as it is coming are getting stored, you can also go back and play a portion of the clip again. So, these facilities are available, which are available in all normal media players. But however, whenever you are doing a fast forward, pause, play, some initial delay is required for the client to get resynchronized with the server, because the client will have to get to the point from where the playback has to start again. That initial delay has to be there before the playback again starts, right. Next, let us come to streaming live multimedia. Now, in streaming live multimedia, the concept is similar, but the difference is that it is live, which means the multimedia content that we are trying to play, it is not stored anywhere beforehand a priori. The multimedia content is generated on the fly and broadcast over the network. Some typical examples, you might have seen these examples, this couple of examples I have shown here. Live news feed. There are many websites through which you can get online and live video clips that broadcast news, or live cricket matches. These are something which are not pre-recorded. these are coming to you live. Cricket match is going on in the field, you can see it on your screen, the cricket match is going on. These are examples of live streaming video feeds. Okay. So, conceptually live and stored are similar. In stored mechanism, the file is stored somewhere, from there the file is getting transferred. In live, there is a camera. Suppose if we talk about video, there is a camera which is capturing the video images online and is digitizing them into packets online and sending it to the prospective customers or the viewers online. So, the data is coming as they are being generated. After the initial delay, it takes for the data to reach from the source to the destination. After that delay, the video starts playing. Okay. So, now the client here usually has a playback buffer, because whatever comes is stored in a buffer, the content is buffered. Here, since we cannot move into the future, here you can have rewind but no fast forward, because the content of fast forward on a live feed does not make any sense, because you are in the present and whatever you are seeing is present. Okay, you cannot go into the future. You can only do a rewind because it is already stored on your computer. You can go back and see what was there, but you cannot do a fast forward. And a few other constraints, depending on the latency of the path, the live stream may play on the desktop after an initial delay. This delay can be as large as 10 to 20 seconds. It depends on the delay of the path through which the data packets will come to the final destination. That delay can be appreciable, but the delay can be the same for all the packets. So, once they start coming, there will be a continuous flow of packets. And the other constraints are still here, all the constraints for timing, because there should not be too much variability in the delays of the packets to achieve jitter free playback. All these things are there. Fine. The third type I talked about, this is the real time interactive multimedia. So, here the concept is like this. Here there is the concept of interactiveness. Interactive in the sense that the content to be transmitted is decided by the end parties dynamically. Some examples I am showing, I will just explain with these: IP telephony, video conferencing, online games. These three examples I have given. In all these three examples, some kind of multimedia content is transferred to and fro between the two parties. For IP telephony, I speak in my microphone, the other person on the other end also speaks in his or her microphone, data packets flow over the network. Now, this is interactive because the way we normally talk over telephone, after I finish talking, the other person will start talking. We usually do not talk together. Okay? So, exactly when I should start talking will depend on exactly when the other person has stopped talking. So, this is some kind of interactive. So, if the other person continues to talk, does not stop, I will not get a chance to talk. So, this is interactive in that sense. That means exactly when the data has to be sent, it depends on some kind of interactive agreement or protocol. Talking about video conferencing, the concept is the same. Suppose I have a video conferencing system through which I am conducting a class. Well, I am sitting in a small studio with some controls, with a computer in front of me. I can see a screen, and there is a big screen on a big classroom with a camera out there where all the students are sitting and watching. Now, there is a mechanism in which a student can ask a question and I can see it on my screen. I can control the camera from my controls and I can respond to that question. Depending on the question, I will stop my lecture and I will respond to the answer. Now, here you see It's a two-way video transmission because it's video conferencing that is going on. So when the transmission will go on, when it will stop, when it will pause, it depends again on some interactive agreement between the two parties. And lastly, for online games, you can easily understand, typically there are multi-party online games which are played on the internet. Depending on your next move, the other person will decide what to do next. So in many such games, again some multimedia contents are being exchanged. These are some typical examples. So for these kind of real-time applications, the end-to-end delay requirements are very important because there are two parties who are interacting among themselves. And when you say delay, this delay actually refers to the whole or the total delay. It will include the application level delay as well as the network delay. Now, as a very rough rule of thumb, if the delay is about 200 milliseconds, it is considered to be good enough for interactive audio, for making a call, internet call. But if it is more than 500 milliseconds, then it may be very annoying and the audio quality may be unacceptable. Quality means I talk, the other person when he or she starts talking, there will be a gap of about half seconds before I can hear. So I really do not know whether the other person has started talking, that I need to pause and wait till that voice comes back to me. So if there is a long delay, because ultimately this latency is there, whatever I am talking is going to the other end with that particular delay. If that delay is too much, it may become quite annoying during the communication. So usually less than 200 millisecond is considered to be very good, 200 to 400 is considered to be acceptable, more than that is usually considered to be unacceptable. How internet handles multimedia today? See, before trying to address this question, there are a few issues you need to look at. Internet is driven by TCP, UDP and ITP protocols, IP. These are the protocols which drive the internet, and all applications that we see, they uses these protocols as their underlying support for transmission of the packets. Multimedia transport can take place only on top of this because these are only the transport systems available. In these protocols, there is no guarantee on throughput, losses, etc., which are important from the point of view of multimedia applications. Which means if there is some multimedia application sitting on top of TCP, UDP and IP, multimedia application, whatever they want from the network, this TCP, IP, UDP may not be able to provide that. So there is a gap, what the applications want and what the network can provide. Okay. So to the extent possible, internet multimedia application use application level techniques, because at the network level there is not much to do. The protocols which are running on the network level does not provide much help. So you use as much application level technique as possible to get the best out of the underlying network or the service. However, next generation internet which is due to come up can handle this much better, because in the next generation internet, the network infrastructure will be such that quality of service guarantee can be provided to the communicating parties. But in today's internet there is no guarantee about the same. Most of the routers which are there in between, they do not support real time traffic or quality of service parameters, right. Okay. So now let us talk about streaming multimedia, how these are typically implemented. Multimedia on internet. So there are several variations. First let us look at the simple approach. In this simple approach, what we say, the multimedia object is stored as a file on the web server. The client sends a HTTP request and the server sends the file back to the client as an HTTP object. Client will receive the whole file and store it in a buffer, and then it will invoke the media player to play the received file. This is what we still use today for many media types which do not support streaming. When you want to run a particular media file which is stored somewhere, we send a request, we get it back, we save it on our hard disk, then we call our media player and open that file, and that file starts playing. So, here basically it is a download and play mode. There is no streaming, no overlapping or pipelining, and typically the delay is long. You need to download the whole file before the playback can start. So, the picture is like this. Pictorially, the file is stored here attached to the web server. So, web server will be transmitting that file to the web browser. The file will get stored in some folder on the web browser machine, and then the media player will be invoked to play the file. This is the typical flow or scenario in this kind of an environment. Now, let us come to the so called streaming approach. Now, in this approach I am downloading the whole file and then I am playing. In the streaming approach, I should start playing as soon as the data starts coming to me. But you see, if you want to have this, you can have it in a similar way, but there are a few other things to be looked into. So, when I am requesting to view a streaming multimedia content on my desktop, there are some issues. How I am connected to the internet? Is it through a low speed dial up line? Is it through a medium speed internet link, lease line, or is it that the entire thing is happening in a LAN which is very high speed? So, I have a media server in my LAN itself and I am trying to access some media from that LAN. So, speed is important. The kind of media that the server will try to send me should very much be dependent on the speed of the link, the maximum bandwidth that is supported. Okay. So, in the streaming approach, typically the flow is like this. Browser first requests for a meta file from the web server. See, meta file is something I will give an example later. Meta file contains some information about the media I am trying to play. Suppose I am trying to play a music. I request to the web server that please send me the meta file for this particular music. In the meta file, I may have several different things stored like this, that if I have a low speed link, if I want to play it in the low resolution or the low fidelity mode, I should download this file, this link. If I want hi-fi, then I should download this link. In this way, depending on exactly what I want, or if I do not want only the audio, I want to play the whole video clip that contains that audio song, then I may be provided with another link. So, all these things depend on the kind of speed or kind of bandwidth I can provide. Okay. So, first the browser gets the meta file, then it launches or invokes the media player and passes the meta file to it. Now, the browser is nowhere. The media player now starts directly interacting with the web server from using the information stored in the meta file. Server streams audio video object in its HTTP response to the media player. This works, but is usually considered unsatisfactory because you do not have much control here on the playback and it is non-interactive, right. Pictorially this is shown like this. First, web browser and web server interacts. The web browser will be sending some request to the server. The server will be sending back the meta file. After getting back the meta file, the web browser will be invoking the media player. Then the media player will be directly interacting with the web server. So this is how the streaming mode works. Now the next alternative to streaming, we say that we don't burden the web server with everything. The method we have just talked about, there we had said that all the media files are also stored as HTTP objects in the web server. They are requested by HTTP, they are sent back as HTTP objects. But because of constraints in the web server, the quality is often not that good or acceptable. Now what we say is that let us have a separate streaming server. In addition to the web server, there will be another server where only the streaming contents will be stored. This usually provides the best performance. Best performance why? Because here you can use non-HTTP protocols. These may be proprietary, which may be tailor-made for this kind of real-time media downloads. And moreover, HTTP uses TCP. Here you can choose to use UDP instead of TCP for better response, right. So here there are two things. Number one, you are using a separate streaming server. Secondly, interaction between the media player and the streaming server can be using any non-standard or proprietary protocol. That is something which you are allowing. Pictorially it is like this. Now on this side there are two servers, web server, streaming server. The web browser sends a request, gets back, invokes the media player. Media player now connects to the streaming server and starts the download. Now here there are some issues. Normally we have client buffering. Client buffering says that as soon as the packets start arriving at the client side, don't start playing immediately. Keep a buffer. Start playing only after certain number of packets have already arrived in the buffer, so that after you have started playing, if there is some delay in some future packet, that delay you can compensate by using that buffer. Okay. So this buffering helps to control network added variable delay and jitter to some extent. But of course, if the variability is too much and continues over long periods of time, then even by using buffering you cannot do much and there will be jitters in the playback. The second thing is that your choice of TCP or UDP. Means for communicating between the media player and the streaming server, do you want to use TCP or UDP? Now if you choose to use TCP, there are a few points here. In TCP, you know, TCP tries to provide a reliable link. So if actually there is a packet which has not arrived, TCP will send back an explicit request for the packet, wait for the packet to come back, and once the entire message has come back in its entirety, then only it will be forwarded to the application on top. But the application here is the streaming media player. The application has to wait for so long. A request going, the packet again coming back, correctly receiving all the pieces, and then only it will get the next chunk of data. So the transfer rate fluctuates due to TCP congestion control. Delays of the packets will be variable and the transfer rates will therefore fluctuate. Quality is better, means once you have received, your quality will be better because there is no packet loss. All packets have arrived and you can get exact playback. Just the case I have said that because of retransmission, because of non-arrival or error in the packets, there can be more delay variations in TCP. However, if you choose to use UDP, the server can send the data at an appropriate rate for the client. UDP does not depend on network congestion. Depending on the present network situation, the UDP packets can find any arbitrary load and will reach the final destination. TCP, there is a congestion control mechanism due to which there are a lot of overheads and there can be delay variations. When UDP is a very lightweight protocol, there is no such congestion control mechanism here. Okay. So, typically the data rate will remain approximately the same. The sending rate of the data will be the rate at which we will be encoding the data into digital form, and this will be approximately constant. But there will be network delay jitter, there will be some variability. So, you can have a short play out delay in the range of 2 to 5 seconds to compensate for this. So, in general UDP works better than TCP when you are having a streaming kind of an application. This is what you should remember. And variability in client rate is something which I was talking about, that how to handle variations in client receive rate capabilities. As I said, some user may be having a dial-up connection, only 33 kbps bandwidth, some may be having leased line 2 Mbps, some may be having the streaming server as well as the client on the same LAN, so there can be 100 Mbps Ethernet connection. See, if you have these 3 different kinds of connection, these 3 examples I have taken, so the rate at which you can pump data onto the desktop will be very much different, and it will not be, you can say, a good idea to choose the worst scenario, that means assume the link to be slowest, accordingly do some encoding of audio or video so that you can transmit data at that slow rate at a low quality, because a person having a 100 Mbps connectivity to the server will not like that quality of playback, they will want very high quality. So, the solution goes like this, that you can have multiple copies of the same media encoded in several different formats stored in the streaming server. Like I am giving an example, suppose our national anthem. So, our national anthem Jana Gana Mana you can store in a very high resolution hi-fi format that of course will take more number of megabytes for storage. You can store it in a medium resolution format that can take 1 or 2 megabytes. You can store it in a low resolution format which will not of course be DVD quality audio, which will take possibly a few kilobytes of storage. So, depending on the requirement of the client, depending on the capability of the client will send a request for the appropriate type of media. The streaming server will be trying to send the correct kind of media to suit the bandwidth constraints. So, just what I had said, the common solution here is server will store multiple copies of the same content which are encoded at different rates and hence will occupy different sizes on the disk and will occupy and will also require different bit rates for real time transmission on the client desktops. Some protocols have been designed at the application layer level to give some breathing space to the multimedia applications, and one such is the real time streaming protocol RTSP. Now, a real time streaming protocol is, as I said, this is a protocol which is working at the application layer level. Underlying TCP, IP, UDP, whatever is there, it's there. Now, RTSP tries to provide some facilities which are very much relevant to multimedia streaming applications. This RTSP allows users to have much better control over streaming media. Now, RTSP is basically a client server protocol. The kind of controls that it provides to the users are pause, play, rewind, forward, repositioning. So, you can move the play cursor forward and backward, you can play pause, you can press play in whatever you want, and this RTSP protocol has a feature to handle all these needs. Now, as I said, when you have RTSP, when you for example do a fast forward, RTSP protocol will be sending a request to the streaming server that from now on you start sending the packet from the requested position, so that wherever I pulled the pointer, from there playback will start, right. So, this is what RTSP is. But RTSP, what it does not do, it does not specify the encoding mechanism. It does not specify how the media is encoded, how it is compressed. This is entirely left open. It also does not tell you whether you use TCP or UDP. It is your choice, you can use both. And how much buffer client has to have for jitter free playback, for controlling jitters, that is also not specified, because these are some things which can vary very widely depending on the kind of network, the kind of users, the kind of multimedia stream you want to view, and so on. Okay. So, this RTSP does not impose any kind of constraint on these kind of variations. Let us see how RTSP works in general. You remember in the FTP protocol, there was one port number for the control connection, one for the data connection. RTSP does the same thing, and this is a technical name. This is called out of band control. In RTSP also, there is one connection through which the control requests and acknowledgements come. There is another connection through which the streaming data are transmitted. There are two channels. The RTSP control messages, as I mentioned, uses different port number than media stream. It uses a port number of 554, and the media stream is considered to be in band and control messages is considered to be out band. This is the convention. Now, a typical scenario out here will be like this. Well, here also we have the concept of a meta file. The file will contain the relevant information, as I said, about the different versions of the same media which is stored, their encoding formats and so on, and the respective name of the files. So, the meta file is first sent to the web browser over HTTP. The browser launches the media player. Now, the media player will be setting up an RTSP control connection. This is the so called that proprietary connection I was talking about. Of course, RTSP has emerged as a standard, but at the beginning this was a proprietary protocol. This was not TCP, not UDP. So, the Windows media player will be setting up RTSP connection with the server, with the content server or the streaming server, and a data connection also. So, these two connections will allow the media player to communicate to the server and request for the appropriate media content. Here there are two servers in existence, a web server and a stream server. So, just to summarize, the browser will first get the meta file, the browser will launch the media player. Media player will initiate a control connection with the server. It will initiate an RTSP connection for the data stream with the streaming server, and then the transactions will go on. There will be some simple, I will give an example later how the typical commands are. Now, this diagram shows you how a typical meta file will look like. This is a typical meta file. This has been coded in an XML like language. There are some tags you can see, which are, these are HTML like tags. It starts with a title. There is a tag called session. This indicates the present session, that what we want to do in this present session. There are several things which you can group together. This begin group, end group, this indicates the group, and in the group there are a number of optional parameters, like here we have mentioned language should be English, EN. There is a switch statement inside group. See, inside group you see there are two statements, one is a switch statement, other is a track statement. Now, inside the switch statement there are two tracks. Switch statement actually means, say inside a switch statement you can put more than one track statements, and you will be selecting one of the track statements, and if we have two statements inside a group, they are all consecutive together, you have to do both, right. So, this actually tells, this is the example of a trailer. This tells you that in the group there are two things. In the first one there is an alternative in the switch. First, there are two tracks. First track says type equal to audio, E equal to some code here. This actually tells you what kind of encoding you have used, and source, exactly what is the name of the file. Second one says, again if type is audio and the encoding is different, there are some additional parameters you can specify. This actually indicates a hi-fi audio stream, DVD quality, then you contact or try to download this particular file, right, this one. So, in the first switch statement, depending on the capabilities of the media player will be asking for one of these two, and in addition there will also be another track which contains video of type video, RTSP stream.com, some URL is again here. So, actually this meta file tells you that whatever you are downloading, it will consist of one audio file. Here you have an alternative, you either download the low fidelity or high fidelity audio file, and you have a video file. You download both and play it on your media player. So, essentially what you get, you will be viewing the trailer on it, you will be seeing the video clip, you will also be hearing the audio. Okay. So, let us look at a typical RTSP operation scenario. This diagram actually shows you what kind of commands and responses go between the web servers, browsers and the servers. You see here there are four entities. First one is the web browser, then we have the web server, you have the media player, you have the streaming server or the media server, whatever you call. First, the web server must send an HTTP GET request to the web server to get back the meta file. So, here we are showing, we are just mentioning it as the presentation description. This is the meta file. After getting the meta file, as I said, the web browser will be forwarding the meta file to the media player, so that now the media player can take up the issue with the media server. Here in an entire session there are several phases, as this diagram shows. There is a setup phase. Media player sends a request, media server sends back a response. This is the setup. Play, media player sends a request, media server sends back a response. This is a play. After this, media stream will be continuously downloaded. This yellow arrow indicates that. This will be the most, you can say, time consuming in this entire session, media stream download. Media player can pause the playback. So, pause and pause acknowledge. See, not only playback, downloading can be paused. When a pause request is sent to the media server, then downloading of the media stream is blocked. And finally, you can totally close down the connection by sending a so called tear down message. So, the connection is torn down and the connection gets broken after getting back an acknowledgement from the server. So, these are the different phases or the different message exchanges that goes on between the web browser and the client and the server. Server, as I said, there is a web server, there is a streaming media server. So, between one of these two, this kind of communication or transaction goes on. Now, let us look at a typical message exchange scenario in RTSP. C indicates clients, S indicates the servers. So, I am assuming in this diagram again that this initial downloading is already done, of the meta file is done. Meta file has been given to the media player and media player starts its communication with the media server. First is the setup command. From the meta file, the media player can find out which particular file it wants to download. So, in setup, it specifies the name of that file and some RTSP version. There is a particular syntax of this command and some additional data that you want transport to be done over RTP UDP. You want compression, port number to be used 3056 and mode is play, which means you are wanting to play the media downloaded. Server responds by its own version and some message code and some session identifier. Now, after getting back this response, client sends a request for the explicit file, which particular file it wants to play. First command was the general command trailer audio. Now, here trailer audio low fidelity. Now, here client also sends some additional information like the session ID and some range. I am not going into detail of these parameters, but it basically tells that exactly what bit rate is to be followed and what is the range of this media it wants to play. 0 dash means from 0 it wants to play till the end. Then sometime later, see, the client can send a pause message. Pause the name of the file and it says that you pause at an index of 37. Okay, go there and pause. Finally, the client can say tear down the name of the file, again the same of the name here, the session name is specified here, and finally the server responds with this message and the connection breaks. So, actually what I mentioned here is that these are the low level commands which flow between the media player and the media server, depending on what the user has clicked on the media player. User may click on pause, play, fast forward, whatever. If it is fast forward, then the media player will know exactly where the pointer has been set. So, a pause message will go to the streaming server specifying the exact relative location, which frame number has to be the next one being downloaded. So, in this way, using the simple protocol, see, this protocol is specifically meant for downloading and controlling multimedia messages. So, using this protocol you can get much better performance as compared to doing everything over HTTP, right. This is in that sense a so called proprietary protocol running on top of UDP or TCP, whatever. So, with this we come to the end of lecture number 36. First we see that what were the answers to the questions we posed during our last lecture. How is e-business different from e-commerce? Well, e-commerce, as I said, is the process of buying, selling products or services over the network. E-business includes all these things. In addition, it includes servicing customers, collaborating with other business partners, or carrying out transactions electronically within an organization. These also fall under the purview of e-business. What is m-commerce? Why is it considered to be important in modern day scenario? E-commerce used in a wireless mobile environment is an m-commerce. Basically, this has become very important nowadays with the proliferation of mobile phones and other handheld gadgets, and their increasing use to carry out transactions. This is the main motivating factor behind having this m-commerce applications being developed, and it is considered to be one of the hottest applications to hit the market in the near future. Okay. What benefits can e-commerce provide to consumers? E-commerce allows consumers to do shopping 24 hours a day from any geographic location, exercise a wide variety of choices, make quick product and price comparisons, have virtual auctions wherever permissible. What are the requirements of a good electronic payment system? The desirable properties are as follows, as I mentioned during the last class: should be widely accepted, convenient to use, very hard to tamper with, and should be based on well established security principles. Well, if you say today that I have developed a new security algorithm, I am using it, no one will trust you, because no one really knows how good or how bad your security algorithm is. Okay. What are card not present transactions? How are they handled in the internet shopping? They are transactions where the merchant do not physically check or verify the credit card, because they are not physically present there. These type of transactions are carried out in internet shopping. As I mentioned again, for security, online verification is essential, and this online verification is typically done by a trusted third party. Now some questions from today's lecture. What is a multimedia application? What are the factors that affect the quality of streaming multimedia contents? What is streaming stored multimedia? What is streaming live multimedia? What is real-time interactive multimedia? The three different types. What is the purpose of the streaming server in the internet scenario? Explain the role of metafile in the context of multimedia streaming over internet. What is RTSP? What are the different steps that are followed by the RTSP protocol for playing multimedia content on a client machine? So, with this we come to the end of today's lecture. In our next lecture, we shall be continuing our discussion on multimedia and real-time contents over the internet. We shall be talking of some standards, we shall be talking about IP telephony and some other kind of applications which can be built using the standards that we will be talking about. Thank you.